All right, so I think I'm recording. Let's take a look at problems 5 and 6. These are asking us to determine whether the given function is even, odd, or neither. So we can break it down into parts. What we first want to do in part A is find an expression for the function when it's evaluated. Let me move this out of the way. When it's evaluated at the opposite of x. So what does this function always do to the input? No matter what you give it, whether it's a number or an expression, what this function does is it creates a fraction. And the numerator here is always 1. And in the denominator, it takes the input, no matter what that input is. So let's just write imp here. Let me make this. If in between the parentheses here is the input to your function. This function creates an addition problem where the first term is a fraction. The numerator of that fraction is always 1. The denominator is always a subtraction problem where you square the input and then subtract 1. Now, that's the first term. The second term is always just plus 2. It doesn't change. It's always plus 2. All right. Now, what they're asking us to do is to have the input be the opposite of x. So, if the input is the opposite of x, everywhere we see that we had the input, which originally was x, we write the opposite of x. Alright. So I'm going to erase this top equation here, because now I have my expression, but I need to simplify it, because I need to be able to compare this against the original. So I need to simplify the right-hand side. Well, 1 in the numerator, that's already simplified. What does it mean when the base is negative x being squared? Well, it means negative x times negative x, and negative times negative is positive. That first term there just simplifies to x squared. Then it's minus 1, and then it's plus 2. And there's my answer for part A. Now, I'm going to use this answer in part A to help me answer it in part C when I try to determine if this is even, odd, or neither. But that's what they're asking me for in part A, is just this expression. So boom, there's my answer for part A. Alright, I'm going to shrink this up and move it out of my way, because like I say, I'm going to return to that when I get to part C. I'm going to need that answer. Well, actually, I'm going to use it right away now in part B. Alright, so we've answered part A. Let's come in and answer part B. Same function. This time it's asking us to take the opposite of f evaluated at negative x. Well, hey, we just found what f evaluated at negative x is, so all we have to do is take the opposite of each term. Well, I have to make a decision. Am I going to put the negative sign in the numerator or denominator? I'm going to put it in the numerator. It's easiest just to make that positive 1 and negative 1. So now this first term and this first term are opposites of each other. And since I'm taking the opposite of the left-hand side with this negative sign, I took the opposite of the first term, I have to take the opposite of the second term. So guess what? There's my answer for part B. See, it couldn't be easier. Alright. So how am I going to use those two answers to truly, this is what we were building up to. This is the main thing of interest here. How can we use these to identify if this function is even, odd, or neither? Well, let's look at our answer in part A. And let's look at our answer in part B, and let's compare them against this original function. In part A, we see that we found the f evaluated at negative x. Well, when you compare this against the original function, let's highlight that original function here. Oop, I was going to use gray. There's my original function. Well, look at that first term. It's 1 over x squared minus 1. Look at this first term. 1 over x squared minus 1. Then you're adding 2. Hey, we're adding 2. Wow, those are the same. So my answer A is the same as the original function. That tells me this is an even function. And I know it can't be even and odd at the same time, but let's go ahead and just really convince ourselves that even is correct, that it's not odd. If I compare my answer in B against the original expression, well, look at that first term. In the original expression, it was positive 1 in the numerator. And here it's a negative 1. The denominators are the same, x squared minus 1 and x squared minus 1. But look, the numerator's positive 1, the numerator's negative 1. This guy is not equal. My answer in B is not equal to the original function. That's telling me, that's convincing me that it's not an odd function. So in part C, we found, hey, we recognized our answer in A was the same as the original. So my answer for C, this is an even function. Oops. I'm trying to highlight in yellow what my final answers were. So my final answer for part A, it said find f evaluated at negative x. On the right hand side there, I found it. In part B, what's the opposite? It asked to find negative f evaluated at negative x. On the right hand side there, boom, found it. Since A was the same as the original, it was an even function. There's my answer in C. Done. Let's see if we can do the same idea for problem 6. Directions are the same. It's asking us to determine if this is even or odd function, so we're breaking it down into steps. And in part A, we're finding an expression for this function evaluated at negative x. What does this function do to the input? No matter what the input is, if it's something simple or complicated, this function always does the same thing. It always creates a subtraction problem. So the first term, the first number, is 2 times whatever we give it cubed. So whatever we give it, we're going to raise it to the third power. That's what this, here's the input x, and that's what it's saying, 2x cubed. See, this x is often referred to as a dummy variable. They could have used x, they could have used a smiley face, they could have used the word input like I'm doing. But I'm trying to illustrate that this function has a rule, and it's very good and very consistent at applying that rule. So here, you put the input over here as well to figure out what the second number is. If it were just the number 2, hey, we'd replace the 2 where it says input. But we want to find f evaluated at negative x. We want this input to be negative x. So we come in, and everywhere we saw the x, we recognize that was everywhere we see input, we put a negative x. Now, we need to compare this to the original function. Well, it's not simplified. It's not an easy comparison right now. I need to think about how to simplify this to make it easier to compare. So this f evaluated at negative x, well, here you have a negative base raised to an odd power. I have a negative times a negative times a negative. That's going to be a negative value there. So I have negative 2 times x raised to the third power. And look here, I have a negative and another negative sign. That's going to change to addition. Boom, there's my answer for part A. They said to find f evaluated at negative x. We found it. Let's save our answer, because just like before, we're going to use this answer to help us in part C to determine whether this is even, odd, or neither. Actually, I'm going to go ahead and use it in part B right now, because in part B, it's saying, look, this f evaluated at negative x, well, now there's a negative sign. It's saying take the opposite of your answer in A. So if I use this answer from A, if on the left-hand side I'm taking the opposite, I have to take the opposite of the right-hand side. And when I have more than one term, that means taking the opposite of every term. That first term, the opposite of negative 2x cubed is positive 2x cubed. The opposite of adding 8x, subtract 8x. So I have to make sure I don't make a mistake in A, because I'm using my answer in A to build the rest of my answers. If I get A wrong, I could get everything wrong. All right, so now let's use our answers from A and B to answer our part C. Is it even, odd, or neither? That means we need to compare the expression against the original. So in part A, let's take the f evaluated at negative x, and the question is it equal to the original function? Well, the first term is negative 2x cubed. The first term is positive 2x cubed. That answers the question. They're not equal to each other. And if A is not equal to the original one, hey, I know it's not even. Now, in part B, I took the opposite. Question is that equal to the original function? Let's compare it and see. First term is 2x cubed. Hey, the first term is 2x cubed. Those are the same. Then I'm subtracting 8x here. I'm also subtracting 8x there. Hey, guess what? Those are equal to each other. So, since our answer B was equal to the original expression, it's an odd function. So we know our answer in C, hey, this guy's an odd function. If you were to graph it, you would see symmetry with respect to the origin. So I hope that helps. In problem 5, it was an even function because the answer in A was the same as the original. In problem 6, it's an odd function because answer B was equal to the original. Had neither one of them been equal to the original, it would have been neither. Hope that helps, and I'll continue making more of these solutions. Talk to you later.